Hello everyone, welcome. Can you hear me? Response please.
Yes, sir, we can.
Okay, so we wait 1 or 2 minutes for another participant join. Then we will start our main session. Okay. Okay, so hopefully all of the participants hear me perfectly. And first of all, I simply share my screen. Okay, so hopefully my screen is visible right now. Yes or no? Response please. So hi and welcome to the 8 days online training program on Google Earth Engine for remote sensing analysis. I am a course coordinator. All of the information already I mentioned in our first number of session. So this is our total course outline. Already I mentioned in our first number of session. That's why I skip these parts. So okay, already we complete our first number of session. Okay. So this is our second number of session. So in second day's course item, we will learn. First item is how to filtering satellite images in Google Earth Engine platform. Okay, any satellite images, suppose Sentinel satellite imagery or Landsat satellite imagery or MODIS satellite imagery. Okay, first of all, we learn how you can easily filter any satellite images in Google Earth Engine platform by your suppose if you want, you can easily filter your Sentinel satellite imagery, Landsat satellite imagery, or MODIS satellite imagery, or other satellite imagery from Google Earth Engine public data catalog. Okay, then we learn how to displaying this satellite imagery. That means how to display any satellite imagery in Google Earth Engine platform, as well as suppose Sentinel, MODIS, or Landsat, any satellite imagery in Google Earth Engine platform. Then we learn different type of band combination using satellite imagery. Okay, band combinations. Okay, using any satellite imagery, then we will learn band combination of different data set in Google Earth Engine platform for your analysis. Okay, and also we learn how to export. Okay, how to export any satellite imagery in Google Earth Engine platform. Suppose you make your analysis easier in Google Earth Engine code editor. Okay, you make your analysis and then you want to export this satellite imagery using Google Earth Engine platform. Suppose Sentinel satellite imagery, Landsat, or as well as any satellite imagery. If you want, you can easily make your analysis and export using Google Earth Engine platform. So we learn these items, and then also we learn how to import. Okay, how you can easily import, filter, reduce, clip, and display any satellite data or any satellite imagery and visualize in your Google Earth Engine map interactive part. Okay, so that means how you can easily import and any satellite imagery, how you can easily filter this satellite imagery. Suppose filtered using your study area, then suppose filtered you use your specific time frame, specific metadata data, and if you filter your satellite images, then you reduce this image collection. Okay, from lots of images, how you can easily reduce your image collection. Okay, and also lots of reduce search function in Google Earth Engine available in Google Earth Engine platform. We will learn all of the things, and also how you can easily only intersect, only clip your own study area and display the final result in Google Earth Engine code editor and map interactive view. Also, we learn in our second day course item, we learn how to calculate any indices, suppose NDVI, okay, NDWI or NDBI. NDVI means normalized reference vegetation index. NDWI means normalized difference water index. NDBI means normalized difference wind up index from satellite imagery, suppose Landsat or Sentinel or MODIS. Okay, how you can easily calculate any indices or any index, suppose NDVI, NDWI, NDBI, we learn in our second session. Then we learn how to make time series chart. Okay, how you can easily make time series chart for NDVI, NDWI from MODIS, and as well as Landsat dataset. Okay, and then we learn how to create or make. Okay, how you can easily create any shape file of the any region of the earth or any region of the world. Okay, how you can easily make any study area shape file and export this shape file using Google Earth Engine platform. Okay, this shape file is geo-referencing. That means you can easily use this shape file in your ArcMap application, ArcGIS application, or QGIS application. That means any geospatial analysis platform, you can easily use this shape file for your any analysis purpose. Okay, how you can easily make shape file of any small or any big region of the world and export it using Google Earth Engine platform. And also, this is our total second day course item. We will learn all of the things step by step. And now you see here the two images already I mentioned. This is our Google Earth Engine public data catalog. Okay, you see here the two images. That means every images I identify, or every images indicate every data set. Okay, suppose you see here the AHN Netherlands 0.5 meter dam data set. Okay, you see here the Canada AAFC annual crop inventory dataset. Okay, lots of dataset available in Google Earth Engine platform or Google Earth Engine public data catalog. Just for example, I put here, you see here the vegetation dataset, also LST dataset, land cover dataset, okay, dam dataset, lots of the dataset, water body analysis dataset available in Google Earth Engine public data catalog. And now you see here that this is a Google Earth Engine public data catalog. In Google Earth Engine public data catalog, you see here the lots of data set available. Just for example, shortly we discuss it. So Landsat, you see here the from this Landsat data set, you see here the Landsat 5, Landsat 4, Landsat 7, Landsat 8, and also every data set has raw images, top atmospheric reflectance, surface reflectance data set individually. Okay, individually. And also you see here the MODIS satellite data set. Suppose MODIS daily product LST, okay, Modis LST, Modis NDVI, okay, Modis daily product for LST NDVI, okay, and also 8 days interval data set, and also 16 days interval. Okay, lots of the data set available in Modis section. And also you see here the trained data set, suppose SRTM, NASA SRTM data set, NEDL data set, GTOPO data set, and also you see here the land cover data set, that means globe cover or ESA or NLCD, lots of the land cover dataset available in Google Earth Engine public data catalog. And also you see here the atmospheric dataset, suppose SRIFs, that means this indicate the precipitation dataset, NOAA dataset, NOAA, lots of the atmospheric dataset available, and also they updating daily. Okay, and more many more they are updating daily. Okay, in Google Earth Engine public data catalog, more than 400 public dataset available. Okay, more than 400 to 500 public dataset available. This dataset totally free for user. Okay, and also they daily they updating more than 4,000 images. Okay, they update daily. Okay, and also if you want, you can easily access more than 5 petabytes of data. Okay, more than 5 petabytes of data you can easily access in Google Earth Engine public data catalog. So that's why some example images already I put in our in my presentation slide. And then you see here the Google Earth Engine public data catalog address. This is our Google Earth Engine public data catalog address. Okay, that means developers.google.com/earth engine slash datasets slash. Okay, this is our Google Earth Engine public data catalog link or address. After some time we will see it live. Okay, so no problem. So okay, first of all we'll learn this thing. So wait a minute, no problem. Okay, so now I simply go to my code editor. Suppose we open code.earthengine.google.com. This is our Google Earth Engine code editor. We simply open and you click on this search place. Okay, and all of the data set you see here. You see here the browse data catalog. Okay, when you click on this browse data catalog, you see the Google Earth Engine public data catalog. You see here the view all data set. Okay, now you see here the climate and weather data set, surface temperature data set, climate data set, atmospheric data set, weather data set. Okay, image Landsat, Sentinel, Modis, high resolution imagery, geospatial, that means terrain data set, land cover data set, cropland data set, other geophysical data set. Already I may mention. Okay, when you click on this button, view all data set. Now you see here, these are all of the Google Earth Engine public data set available in here. Wait a minute, maybe networking issue. Okay, so now see here the already I mentioned all of the data set. Okay, already I mentioned shortly all of the data set. So now you see here, wait a minute, public data catalog. From this public data catalog, already I mentioned these images. Suppose this is, you see here the annual crop inventory data set, okay, of this region, Canada, AAFC, and also you see here the Netherlands 0.5 meter dam. Okay, lots of the data set. You see the Star, okay, L1T data set, Australian 5 meter dam data set, and also you see here lots of the data sets. Suppose coupled evapotranspiration and gross primary product. That means GPP. Okay, the dataset available in Google Earth Engine public data catalog, and also use the SRTM, that means digital elevation data, DEM data. Okay, and also you see here lots of dataset available. Okay, suppose you see here the Copernicus foreign land cover dataset, and also you see here the Copernicus DEM dataset, Sentinel 1 SAR data, CRD, C-band, synthetic, this data set, and also it's the harmonized Sentinel multi-spectral instrument data set. If you want, you can easily use any satellite data set and make your analysis from Google Earth Engine public data catalog. Okay, all of the data set available. You see here the more than 4 to 500 data set available in Google Earth Engine public data set. Okay, so don't worry. So then we learn. Okay, we learn our specifically how you can easily import. Okay, how you can easily import any satellite data set in your code editor. Already briefly we learn in our first number of session. So, so how you can easily import, filter, reduce, clip, and display this satellite data in Google Earth Engine code editor. Suppose how you can easily import this data from Earth Engine public data catalog to code editor. Like suppose any satellite data set, Sentinel, Modis, Landsat, or any satellite data set. Then how you can easily filter this data? Okay, how you can easily filter by your specific time frame, filtered for your specific study area, filtered by your specific image metadata. Suppose if you want, you can use select less than 1% cloud cover, or less than 5%, or less than 10%. Okay, then how you can easily reduce this image collection by using your region of interest, specific time frame metadata, and also how to clip your own study area. And own study area, that means your shape file, or your specific location, or your specific geometry. How you can easily only clip your own study area. Okay, own study geometry. Then finally, how you can easily display the result in your map interactive view. And after, how if you need, how you can easily reprojected scale pixel if need, when you handle any satellite data set, and they supply extra scale pixel for reprojection. Okay, then we reproject the scale pixel, and we extract our actual result. Okay, so don't worry about this. All of the thing we learn step by step. So let's go. So first of all, we import any satellite data set in our code editor. Suppose we click on this code editor, and suppose we click on this browse data catalog. Okay, from this browse data catalog option, suppose randomly we select, suppose you see here the Landsat. Okay, you see here the view all dataset option, and you see here the Landsat, Sentinel, and Modis section. Okay, suppose if you want to see the Landsat dataset, suppose just we click on this Landsat, and you see here the lots of Landsat dataset available. Suppose collection 2. Okay, you see the Landsat 9. Okay, this is our update Landsat dataset. Is this sensor start capturing of the image from year up to 2021. Okay, this is a Landsat 9 OL2 and TIRS2 dataset. And also you see the Landsat 8 dataset, Landsat 7 ETM dataset, and also you see the Landsat 5 TM dataset, Landsat 4 TM dataset, and Landsat 1 to 5 MSS multi-spectral instrument dataset. You see here this start. Suppose randomly we select one. Okay, and also if you want, you can use suppose Sentinel dataset. If you want to use, if you want to make your analysis with any Sentinel imagery, you see here the lots of the Sentinel dataset available. Is a Sentinel 1 SAR GRD dataset. Okay, and also Sentinel 2 multi-spectral instrument dataset, and also you see here the Sentinel 3 OLCI. Okay, ocean and land uh, color instrument dataset, and also you see the Sentinel 5 Tropomi. Okay, that means tropospheric monitoring instrument dataset, and also lots of the suppose LULC. You see here the ESA world cover dataset, and also you see here the Sentinel 2 cloud probability dataset. Okay, lots of the dataset available here. If you want to see the Modis satellite, okay, just for if you want, you can easily use here the Modis section. Now you see here the lots of the Modis dataset available. All of the dataset is daily product. Okay, you see here the all of the dataset indicate daily product, and as well as available 8 days interval product, 16 days interval. Okay, you see here that if for this dataset, you see here the Terra vegetation continuous field yearly global 250-meter resolution dataset. Also, you see here the Modis. Okay, you see here the Modis land LC. Okay, Modis land cover type yearly global dataset, and also you see here the surface radiation dataset, and also you see here, wait a minute. Also you see here this lens surface BFR the daily dataset. Okay, lots of the MODIS dataset available here. When you use practically, we will learn all of the things. Okay, details of any every satellite dataset. You see here the LST. This is our LST dataset. Okay, that means land surface temperature and emissivity daily, and also you see here the land surface temperature and emissivity 8 days interval, and also you see here the vegetation. Okay, Terra vegetation, and also as well as you see here the aqua vegetation. That means aqua indicate the water and terra indicate the land area or surface. Okay, so we learn all of the things, no problem. Suppose from the Sentinel, MODIS or Landsat dataset, randomly we select this Landsat one. Okay, suppose randomly we select this Landsat dataset, and also you see here the Landsat 9, Landsat 8, Landsat 7, Landsat 5, 4, all of the Landsat dataset available here in this Landsat section. So now suppose randomly we select one. Suppose we randomly select Sentinel 7, 8, or 9. Suppose randomly we select this Sentinel 9 dataset. That means, sorry, Landsat 9 dataset. This is our update. Okay. And also you see here the Landsat 9 section. You see here the surface reflectance dataset imagery, top atmospheric reflectance imagery, and raw images. Okay. Suppose from here randomly we select this top atmospheric reflectance dataset. Okay. Suppose randomly we select top atmospheric reflectance, and also you see here the all of the description of this dataset available here. USGS Landsat 9 collection to tier 1 top atmospheric reflectance dataset. Okay, and this dataset availability time year of 2021 October. Okay, 31st October to update time. That means present time. Okay, you see here the year of 2025, and also 16 January. Okay, 16 January, and also you see here the dataset wider information USGS slash Google, and also you see here the Earth Engine Snapchat. Okay, so we use this Earth Engine Snapchat and import this dataset in our code editor, and also you see here the description of this dataset. You see here the Landsat 9 collection to tier 1 top atmospheric TOA reflectance dataset calibration coefficient are extracted from the image metadata. Okay, all of the information of this dataset Landsat 9 available here. Also you see here the band history. Okay, you see here the lots of the band, all of the band available in this dataset. Suppose B1 band. Okay, pixel size is 30 meters, resolution wavelength is 0.43 to 0.45 micrometer. Okay, also B1 band indicate. Okay, you see here the description is coastal aerosol band. Okay, B1 band indicate the coastal aerosol band, and B2 band indicate the blue band, B3 band indicate the green band, B4 indicate the red band, B5 indicate the near infrared band, that means NIR band, B6 indicate the short wave infrared 1, that means SWIR 1 band, B7 indicate the short wave infrared 2. Okay, and also all of the working band is 30 meter pixel size. Okay, and also all of the wavelength of this band available here. Okay, also you see here the B10 band. Okay, B10 band indicate the thermal infrared band. If you want to make your analysis for LST, we use here the B10 band. That means B10 indicate the thermal band. Okay, for LST, for Landsat LST, okay, we use here the B10 band and also B11 band. Also you see here the thermal infrared band 2. Okay, in Landsat 9 dataset, and also you see here the image properties information. Okay, image property is all of the history of this you see here available here. Okay, you see all step by step we learn all of the things. Okay, so first of all we import this data set in our code editor. Suppose we simply copy this Earth Engine snippet and paste in our code editor. This is the one way for importing any satellite data set. And also we take a var keyword of JavaScript programming in Google Earth Engine Editor VAR, and also set the variable name. Suppose we put at the Landsat 9. Okay, Landsat 9. If you want, you can use any variable name. No problem. Also use at the equal sign. Okay, so this is our total number of images of Landsat 9 top atmospheric dataset, and also this dataset is stored in the variable name is Landsat 9. This is the one way for importing. And another way, suppose we put here the we search here Landsat. Suppose Landsat 9. Okay, you see here the wait a minute, Landsat 9. Okay, now you see here the lots of the Landsat dataset available. When you search here the just put here the Landsat 9, you see here the USGS Landsat 9 the collection to tier 1 top atmosphere reflectance. This dataset already we import in our code editor. If you want to import it, suppose we click on this dataset, and now you see here the all of the description, band, image, history, image properties, all of the information available here. And also if you want to import this dataset in your code editor, just simply copy this snippet and paste in your code editor. This is the one way. And another way is we click to the import button. Okay, below the right side, just we click to the import button. This dataset automatically open in your code editor and set a default variable name is image collection. If you want, you can change this dataset. Suppose we put here the L9, that means Landsat 9. If you want, you can use any variable name, no problem. Okay, and this is the two way for importing. Always we follow this way. Okay, for import any satellite dataset in your code editor from Google Earth Engine public data catalog. Okay, and suppose this one we remove from here and we use this one. Okay, suppose already we put here this Landsat 9 top atmospheric reflectance dataset and stored in the variable name is Landsat 9. Okay, now if you want to check how many images available in this dataset, okay, how many images available in this dataset, just we use the print function and also use the size function. Okay, that means, oh, okay, no problem, wait a minute. We put here the print function and call this dataset variable name. Simply copy this dataset variable name and paste here. Okay, when you click to the run, you see here the wrong issue. Okay, wait a minute. After you see here the our Google Earth Engine server is working. Okay, you see here the EE, that means Earth Engine has server function we automatically use in this Earth Engine snippet. EE, that means Earth Engine dot image collection. Then they put here the Landsat dataset information. Okay, now you see here the image collection is error because this image collection query aborted after accommodating over 5,000 elements. That's why this type of wrong issue show here because user limit access. That's for that we use here the size function. Okay, size. What is our size function? Size function is show as a all of the image number show in our console tab as a round number of images show here. Okay, so now click to the run. So now you see that our number is computing. Okay, so after some time you can easily see how many images available in this Landsat 9 dataset. You can easily show as a integer number. Okay, so this is the way for how if you want to check how many images available in your dataset. Okay, so now we filter it. Okay, suppose by filter your study area. Okay, filter your any region. Okay, now you see here. Okay, now you see here that the exact number of the images. You see here the more than 5 lakhs images. Okay, 5 lakhs 20,000 and 572 images available in this Landsat 9 update dataset. Okay, because you see here that this Landsat 9 image this dataset available time time year of 2021 to present time. That means and also day by day updating. Okay, that means this is a short time. Okay, now if you want to check, suppose we want to check our Landsat 8. Okay, just for example, we click on this Landsat 8 and also okay, now we same thing. Suppose we click on this top atmospheric reflectance dataset and now we copy this Earth Engine snippet. Simply copy and paste in our code editor. Suppose we put here. Okay, suppose now we want to check how many images available in Landsat 8 top atmospheric band. Suppose Landsat we put here the this Landsat 8 variable name dataset is Landsat 8. Okay, so wait a minute. So now if you want to check how many images are available in this Landsat 8 dataset, now we click on we copy this Landsat 8 variable name and also use the size function. Size function is show as a integer number value. Now you see here the two number is computing available here. Wait a minute. After some time you can easily see. Okay, for Landsat 8 and also Landsat 9. Okay, if you want you can use all of the you can see number of images available. Okay, so wait a minute, just we put here suppose Lancet 8, we show Lancet 8 for as a headline we put here, and also and we put here as the headline is suppose Lancet 9. Wait a minute, then we use the okay, now we see here the Lancet 8 and also sorry Lancet 9. Okay, after some time we will see okay how many images available in Lancet 8 and also Lancet 9 dataset. Okay, so the already we filter see how many images available in suppose Lancet 9 dataset. Okay, and then we suppose you see here the more than 5 lakhs images available in this Lancet 9 dataset. Okay, so now then we filtered any our specific area. Okay, suppose for that, so suppose from our map interactive part, suppose randomly we select one area. Okay, suppose randomly we select one area as our specific study area geometry. Okay, wait a minute. Okay, maybe networking issue. Okay, so suppose randomly we select from you see here the lots of the tools available here. Add a marker tool, add a shape, add a draw a rectangle. So suppose we click we show we select this for rectangle this study area, and you see here the four vertices, and automatically this study area shows as a geometry. Suppose this study area we select for our uh, um, geometry. Okay, suppose we put here the variable name is area of interest, AOI. Okay, just for example. Okay, just for example. Okay, for better example, okay, we put here these things, so no problem. And suppose we take a okay, so now you see here the in our Landsat 8 satellite data set, you see here the more than 1.9 million images. Okay, more than 1.9 million images available in this Landsat 8 dataset, because this dataset is time is very long, year of 2013 to present time. Okay, this is our Landsat 8 dataset, so that's why this number of images is very high. You see here the more than 1.9 million images available here. Okay, just for example, suppose we simply remove from here. So now now we use this Lancet 9.1. Okay, so now we these four vertices study area we select as a shape file. Okay, now we filter it. Okay, now we filter step by step. Okay, suppose we take a variable, and variable name is suppose filter geometry. Okay, geometry. If you want, you can use any variable name, no problem. And now we put a variable name is filter geometry, and call our this Landsat 9.1. Okay, Landsat 9 dataset. This Landsat 9 more than 5 lakhs images available. This variable name is Landsat 9. Simply copy this one and paste here, and we use here the filter function. Okay, suppose filter bounce function. Okay, filter bounce function. Okay, what is our filter bounce function? Filter bounce function is intersect our study area. Okay, if you have any question, ask me, no problem. Oh, AOI. Okay, so no problem. Okay, again I relate it. So okay, don't worry. Suppose you relate this import AOI. We just we put here. You see here the study shape. Okay, draw a rectangle shape in our map in interactive part of Google Earth Engine corridor. You see here the draw a rectangle shape, right? Draw a shape and draw a line. Okay, add a marker tool. Okay, so suppose you easily we use draw a rectangle shape. Okay, draw a rectangle. We put here the this right sign, and also now we drag it. Okay, drag and say, select this study area. If you want, you can change this all of the things. Suppose if you want, you can change this ramp of the visualization. Okay, just for okay. Now we click on the okay. Now you see here this type of ramp show in our okay. So now we already put here the geometry, and if you want to change this variable name, suppose if you want, you can use any variable. Suppose study area. Okay, study area. Okay, if you want, you can use any variable name, no problem. Okay, so now we put here any another variable name is filter geometry, and then you call our this more than 5 lakhs images. We put here the Landsat 9 and we use the filter bounds function. Okay, what is our filter bounds function? If you want to learn about this as a new learner or as a beginners, you search here. Okay, in our talk step, because talk step your friend. Okay, as a new learner, always you follow this talk step. Okay, as a new learner. Okay, so now you see here the filter bounds. What is our filter bounds function? Filter, wait a minute, filter. Okay, so filter bounds function. Wait a minute. Again, I simply copy this function and paste here. Okay, what is our filter bounds function? Filter bounds function. Wait a minute. You see here the filter bounds. That means filter bounds shortcut to filter a direction by intersection with geometry. Okay, items in the direction with a footprint that fails to intersect the uh, event geometry will be excluded. Okay, that means we use here our this function, filter bounds function, just intersect our study area. That means from this more than 5 lakhs images, how many images available in our only this study area. Okay, we filter it. Suppose now we use the pin function and we call this our already we use the filter bounds function and also stored in the variable name is filter geometry. Simply copy this variable name and paste here. Okay, and also you use the size function for show as a integer number value. Now click on the run. So now you see here the, okay, wait a minute, maybe not. Okay, you see here the only 271 images available in our study area geometry. Okay, for your better example, just we delete this study area shape, rectangle shape, and we import any asset shape file from asset tab. Okay, just for a better example, suppose already we import our base 24 study area shape file here. Okay, if you want, you can use this. So don't worry about this. Just for example, okay, just for example, suppose we put here this study area. Okay, practice best 23 this shape file import in our code editor as our study area or geometry. Wait a minute. Okay, so this study area we import here. Okay, or anyone. Okay, suppose for better analysis, just we use here the moderate shape file. Okay, wait a minute. Just okay. Wait a minute. From asset tab, we import any study area. Suppose any district shape file. Okay, for your okay. Suppose we put here the Dhaka district shape file because this study area is moderate area. Okay, medium. So suppose we put a variable name is AOI. That means area of interest. If you want, you can use any variable name. No problem. Okay. And now we instead of a study area, we put here the AOI. That means this study area shape file variable name. This is our Dhaka district study area. Wait a minute. Already I import in our asset tab. Okay, from asset we easily use in our code editor. So this shape file we use for example. Okay, so now you see here the our okay now when you click the run, so now you see the 157 images available in our study area. Okay, so now we suppose we put here, suppose we use here the problem. Okay, wait a minute. Suppose we use the map dot center object function for focus our study area. Okay, wait a minute. Study area is AOI. Okay, I'll simply copy this object name and paste here, and also zoom level we select suppose 8 or 9. If you want, you can use the zoom level 0 to 24. Okay, so now click the run. Okay, so now we see our study area in our map interactive part. Okay, so now we, for better showing, we use the map add layer as a layer. Okay, just zoom our layer by using our center object function. Now we put at the map layer. Suppose layer name is we put at the AOI. Okay, first of all, just study area we want to see. Okay, that's why we use at the AOI. And I click the run. So now you see here our study area. We easily see our map interactive. Okay, in our study area, only from this more than 5 lakhs images, we only filtered. Okay, 157 images. Okay, so if you have any question, ask me. Okay, no problem. Okay, so now you see here only in our study area geometry, only we filtered our 157 images. Okay. Okay. If you have any question, ask me. No problem.
Sir, I didn't get the point, man. What is the use of filter bound function?
Okay. Okay. The filter bounds function is attached. That means these more than 5 lakhs images available worldwide, right? Okay. So from this more than 5 lakhs images, we use here filter bounds function and only select our study area. That means our shapefile, and we try to find how many images available in our study area. Understand? So that's why we use the filter. We filter bounds function. That means filter bounds function only access this type of images, which images intersect our this shapefile. Okay, so that's why we use the filter bounds function and attached our study area. Okay, AOI. That means this filter bounds function automatically intersect all of the images from this more than 5 lakhs images with images available in our study area. Okay, so that's why we use this type of function, filter bounds function, and only filtered for our study area. Now you see here the from more than 5 lakhs images, only we filter or select only 157 images in our Dhaka district study area. Okay, so from these 157 images, now we filter again. Suppose we take another variable. Suppose we use the filter time frame. Okay, filter time frame, because suppose your analysis time is 1 month or 1 year or some month. Okay, so filter time frame. Okay, so if you want, you can use any variable name, no problem. Now we call our these 157 images. Okay, these 157 images stored in the variable name is filter geometry, because we call our this total more than 5 lakhs images. Now you see here the Lancet 9, right? We call this Lancet 9. That means total more than 5 lakhs images. Then we filtered our only study area. This is our Dhaka district, and we found only 157 images in our study area geometry. And these 157 images stored in the variable name is filter geometry, right? So now we call this filter geometry variable name. That means our 157 images. Okay, so now we use the filter date function for select our specific analysis time or a specific time frame. So now we click now press control and space at a time. Now we say the start and end. So now we put here the start time and end time. Okay, just for example, now this Lancet 9 dataset available time we see again. So wait a minute. Okay, from this Lancet, okay, this time is year of 2021. Okay, year of 2021 October, hopefully. Okay, now this is a available time. Available 2021 October or 31st October. Okay, no problem. So suppose we put here the suppose we want to select filter only 1 year images for our uh, for our this study area geometry. Suppose we put here the year of 2022. Okay, year of 2022 1st January. Okay, this is our time frame start date. Year of 2022 1st January to year of 2022 31st December. That means this 1 year only we select for our analysis, this time frame. Okay, so now if you want to check how many images available in this study area and also this is this time frame. So now we simply copy this time frame variable name, because already we use this function and stored in the variable name is filter time frame. Simply copy and paste here. Within pin I use the size function for show as the integer number value. Now click to run, and also now you see here the from this 157 images in this time frame. Okay, that means 1 year. Year of 2022 1st January 31st December, only 55 images available. Okay, 55 images available between this time frame. Okay, okay, and also all of the images history is more than suppose 10%, 90% or 100% cloud cover available in these 55 images. Okay, so for your better analysis, for better images, we use here the another function and filtered our image metadata. That means image properties. Okay, cloud or his. Suppose we take a variable and variable name is suppose filter metadata. For better understanding, I set here this type of variable name metadata. Okay, and now we call our this total 55 images. These 55 images is stored in the variable name is filter time frame. Now simply copy this filter time frame variable and paste. Now we use the filter metadata function. Metadata. Okay, not metadata. Sorry. Okay, filter metadata function, and now you see when you click the control and space, you see the name, operator, and value. What is our filter metadata function? Now we see our image property section, and also this first band name is cloud cover. That means this description of this band name is percentage of cloud cover. That means 0 to 100. That means -1 is not calculated. Okay, and also you see here the cloud cover land. That means only land area. Okay, percentage of cloud cover over land. Same thing, 0 to 100, and lots of the information available here. So for filter our cloud metadata, we use this type of this band name. That means cloud cover. So simply copy this cloud cover band name or image property name and paste there. This name is our this band name cloud cover. And operator we select. Suppose we want to select suppose less than. Okay, less than value is 1. Okay, that means less than 1% cloud pixel or cloud percentage images is good for our analysis. Okay, so that's why we put here that this band name is cloud cover, and less than, that means less than 1%. Okay, all of the function, okay, all of the function, filter date function, filter metadata function available in our docs tab of Google Earth Engine docs tab. Okay, as a new learner or as a beginners, docs tab your friend. So that's why we must be follow every time this docs tab. Okay, now you see at the feature collection filter metadata. What is our filter metadata? You see a shortcut to filter collection by metadata. This is equivalent to the filter filter metadata. Return the filtered number of images. Okay, so now you see the operator string. Okay, the name of the comparison operator is less than or equal or greater than, not equals, not less than, not greater than, also start with, okay, end with, no start with, no end with. Okay, lots of the operator string available. So suppose from this operator string we use the less than. That means this one, less than. Okay, less than. Okay, so less than value, then we have the value. That means this value to compare against this object. Okay, that means we put here the cloud cover less than. That means less than 1. That means we want to see how many images available less than 1% cloud cover or cloud pixel percentage. Okay, less than 1. So that now we want to see how many images available less than 1% cloud pixel for better analysis. Okay, now we copy this filter metadata variable name and also paste here, and also use the size function for show as the integer number value. Now click the run. So now you see here. Okay, so now we see only 15 images available, which are less than 1% cloud pixel percentage. Okay, so this is the process for filtering any satellite data set. Okay, suppose from this Landsat 9 satellite imagery, you see here the more than 5 lakhs images available, and from this more than 5 lakhs images we use our study area. Okay, study area, that means we use our geometry or our shape file, and we filtered only from this more than 5 lakhs images only 157 images available in our study shapefile Dhaka district. And from these 157 images, then we filtered, we call our specific time frame. Okay, suppose our specific time frame is 1 year of 2022, 1st January to 31st December. Okay, so from this time frame, okay, between this time frame only we find 55 images, and then from these 55 images, then we filtered our filter metadata function. That means our haze particle or cloud pixel particle available in our satellite imagery. Okay, so that's why we filtered our less amount of haze or less amount of cloud containing images we filtered for our better analysis. That's why we use the filter metadata. And less than 1, if you want to increase it, suppose less than 10%. So now you click the run. So now you see this number is increased. Okay, wait a minute. You see here the you see here the total image number is 21. Okay, if you want to select suppose less than 5%, now you click the run. So now you see here the image number is only 20. Okay, so now we suppose we for our better image filtering we use at the less than 1%. Okay, always we try to find less than 1% images for better analysis. So now you see here the only 15 images available. These images is good for our analysis because these image contains less than 1% cloud history. So now we okay, now with this filter metadata, that means these 15 images we want to see in our map layer. So suppose we copy this filter metadata, and also instead of AOI we put here this filter metadata, and now try to see. Okay, wait a minute. So now you see here. Okay, what is the problem? Because this okay layer one is please try again. Time frame metadata. Okay, no problem. Okay, wait a minute. Okay, so maybe networking issue there. That's why it shows wrong. Okay, so now you see the total 15 tiles. Okay, total 15 tiles available. You just you see here the only this tiles pixel size is 30 meter. Okay, you see already you see here this band information. This pixel size is 30 meter. Okay, so now that's why you see here the square shape side. One image is above another. Okay, one image is above another, and already you see here the total 15 images available here. Okay, if you want to see these images, suppose we withdraw this size function, and now click the run, and now we